Just like with exponentials, the graphs of logarithms have a basic shape, which are affected by our base value. This value right here at the bottom, so log base b of x, where b is going to be a positive number, and we will take on two basic shapes. We see one of them right here. We will create the others. And just like with exponentials, we again have some key points. This is the facts you're going to use to help you graph. And so our key points are 1, 0, B1, like you see listed on the graph to the left. And then we have one extra one, 1 over B negative 1. There is a, so let's label that point right here. This is our 1 over B negative 1. The other two are listed. We do have a standard vertical asymptote always with log functions at x equal to 0. With transformations, we can in fact move this vertical asymptote around, which we will do, right? And like stated before, the vertical asymptote does happen at values not in the domain. And so what we are going to see when it comes to log functions is that if we are taking the log of anything, even if we were to, like, let's say add 1 on the outside, it's that anything for our domain that needs to be greater than 0, right? So what we would do is set the inside equal to 0, which I will in fact show you how to do once we start moving things around. We want that inside bigger than 0. This one, however, not a lot going on, don't need to solve for anything. So in interval notation, I have the interval from 0 to infinity. For my range, we can simply look at the graph. We have our range, right? Starting output starts at negative infinity. Graph goes up and up and up forever, all the way up to positive infinity. So negative infinity to positive infinity. I do want to show you how to do some other graphs, but I will kind of mention before we move on that these facts are true always. Domain, range, vertical asymptote, key points, all of them for non-transformed graph, right? We haven't moved it to the right or to the left, done any reflections, shifts up, down, all that good stuff. Let's take and use these facts here. So your step 1 is to start by identifying the base. So for us, the base right here is 6. And so then what I like to do is I like to list out my key points. Remember, they were 1, 0, B, 1 instead of a B, I'm going to write a 6, since we're going to go ahead and plug some values in. And then 1 over B, so 1 over 6, negative 1. There is a vertical asymptote where the inside is greater than 0, so x greater than 0. At that value is where our vertical asymptote is. So I like to draw my vertical asymptote first, making sure to use a dashed line. There it is, x equal to 0, and then I'll label my key points. 1, 0, 6, 1, right? So 1, 2, 3, 4, 5, 6, somewhere out here. I'm going to go ahead and just place it out there. It's fine. And then -1, 6, -1, somewhere right here. And when I draw my graph, I just like to keep in mind that my graph's never going to cross that vertical asymptote. You see that behavior shooting down to negative infinity, and then this end's going to take off. Let's try the next one. So that is one of our shapes. For this particular graph, where our base is essentially a smaller value, so somewhere between 0 and 1, like 1/6, right? Let's label our key points really quick. We're going to see the other shape happen. So 1, 0, B1, 1 6 over 1. For my 1 over B, so 1 over 1 6, negative 1, I'm actually going to just rewrite that 1 over 1 6 using what I know about division by fractions to adjust a 6. Negative 1. Again, standard vertical asymptote at x where the domain breaks down. So since for this one our domain needs x equal to greater than 0, that's where our vertical asymptote is going to lie, right? So step 1 with my graphing process, I like to draw my vertical asymptote. Oops. And then my key points, 1 0. 1 6 1 is roughly right here, and then 6 negative 1 right over here, just like with our last graph. Again, being sure not to cross that vertical asymptote, shooting my graph quickly up to positive infinity, connecting that last point. And this looks good. So, what I do want to talk about is some of these common functions that we explored last time, and that is our base 10 and base E function. So, if we have base 10, we will commonly write those logs without a base. So if you ever don't see a number here, always assume base 10. For our base E, remember E is approximately 2.17, and it repeats on forever. For our log base E of x, we wrote it as ln of x. This was known as our natural log. So where I'm going to jump in is I'm going to do key points. Start with our base 10 graph, right? 1 0, B1, so 10 1, and then 1 over B, negative 1. Vertical asymptote at x equal to 0. I'll go ahead and get that drawn. Label some points, but I think what I'm going to do here is, since our number is so big, 10, I'm going to jump and change our scale to 4, 6, 8, 10. I think I'm going to keep this scale 1, 2, 3, 4. Negative 1 down here. Let's label some stuff now. So 1 0, I'm going to go ahead and zoom in just a little bit because 1 0 is going to be right here in the middle. 10 1, 1/10 negative 1, just super close to that axis. Connect, don't cross the vertical asymptote. Right? So, let's try the next one. Again, key points. 1 0, B1, 1 over B negative 1. Vertical asymptote at x equal to 0. Draw that vertical asymptote. I'm not going to change the scale of this one. I'm going to let them be 1s. So I have the point 1 0. E1, 2.17 is like somewhere right there. Use a calculator to help me if you like. Since we already have some general shapes in mind, I'm going to go ahead and finish my graph.